the academic world, there is a lot of talk about STEM education: science, technology, engineering, mathematics. Questions arise like, how do we get more Americans interested in careers in science? Let's be realistic. How do we keep more Americans interested in science through high school? How can we better teach science? Now, I want to take that last question and hold it aside for a minute. How can we better teach science? I know right now you're hoping that I'm about to tell you the answer to that. It's going to be amazing. I don't want to crush your dreams, but I don't know the answer to that. The only thing I can assure you is there are a lot of intelligent people working on that problem right now. I actually want to look at those other questions I asked. Let me summarize it like this. How do we pique and maintain student interest in science? Because my argument would be, it doesn't matter how great our teaching methods are, they'll never go into science careers if we don't let them into the game of science. Now, did I just say science was a game? Yes, I did. Let me ask a question. By a show of hands, how many people here have an interest in sports? Maybe you play sports, you watch sports on TV, you read the sports page, maybe you're in a fantasy sports league. Excellent. I can generally only see the first two rows, so I have no idea how many people raise their hands. But I'm not going to ask the corresponding question about science because the results, even in those first two rows, might upset me, and then I wouldn't be much of a speaker. It would be doing a disservice to all of us. But I ask you this. If we engaged kids in sports the same way we do in science, do you think the results would be the same? Let's take an example. You're a young child and you've expressed to me an interest in sports. I say that is great. Step one, memorization. You need to learn facts. You need to know the distance from the pitcher's mound to home plate. You need to know the proper PSI to which a regulation football should be inflated. At the end of the year, I'm going to test you on those facts, and based on your test results, I'm going to determine your athletic ability. It has nothing to do with ever seeing you throw or kick. It's going to be entirely based on how you did on that test. As you get older, don't worry, the problems get more interesting. They become application problems. We're going to add a little mathematics. What percentage of the area of the basketball court is between the three-point lines? Now, you move into middle school. It's going to be an exciting day. Today, the instructor, me, I am going to throw a spiral pass as an example. And if you are the lucky volunteer that I choose to catch it, you are going to get your hands on actual sporting equipment for the first time in your life, and you're only in 7th grade. Oh my goodness! You make it to high school. Now we are going to try and recreate great moments of sports past, but not on the field or the diamond or the court, only in the laboratory. And by the way, if it doesn't actually work the way it did historically, we're going to make no attempt to explain why. While you're working on that lab report, why don't you write me a 10-page argumentative essay, yes or no, the designated hitter rule diminishes the spirit of this game of baseball. Admittedly, that's a game you've never played, but you can do research. Graduation, you hear pomp and circumstance play, and you're off to college. If you're still interested in sports, wow, you are a diehard. But now you're an undergraduate, and you get to get on the field. Not to play the game. Let's not get ahead of ourselves. But you're going to get to do some drills, learn the actual skills that are involved in the sport. If you actually want to play, you better get really good grades in college, and you better do well on the GRE, general and sports subject test, so that you can get to graduate school. And finally, at long last, you will get to play a game, the game that you have dedicated 13 or more years of your life to learning about. You get to play it for the first time. Now, if this was really how we engaged kids in sports, how many adults do you think would still be interested in it? And yet, this is exactly what we do with science. I say we need to change that. I say we need to get the kids into the game. Now, at this point, you're saying to yourself, yeah, but Eric, science isn't a sport. Actually, I hope you're saying to yourself, oh my gosh, he's exactly right. But let's assume a few of you are thinking, yes, but science isn't a sport. And you're absolutely right. It's not a sport. But in all of the important ways, it's just like a sport. We often work in teams. Sometimes there are competing teams going for the same goal. Sometimes you compete as an individual. It has its adrenaline rushes and its miracle moments. And overall, most important, science is fun. Yes, that's exactly what I said, and I mean it. Science is not a bunch of facts. Science is fun. So I propose we find a new way to engage children in sports, and that way is to actually get them involved in the game. Here's what I'm proposing. I call it the blank-wide science project. Not experiment, but project. Now, what do I mean by blank-wide? Well, we're going to scale up. Let's assume we started at the county-wide science project. I want a science project in which every child, kindergarten through 12th grade, is going to be involved in the entire county. It's going to start with meetings, superintendents from all the different districts, sitting down with some people from the state. And I don't necessarily mean the Department of Education, though they're welcome to be there. I'm talking about other departments like environmental protection, public health, transportation, because what we're looking for is a project that will have some significant meaning to the community. Let's take an example. Let's talk about water quality. It would be very beneficial to have a detailed water quality study of lots of water sources from throughout the county. The problem is, of course, one of manpower. To collect water from so many different locations, to analyze all of those different samples, that's going to take a lot of people. Where could we find all those people without raising taxes to fund it? What about the students? We create a science project where the youngest kids, the kids in elementary school, are bringing samples of tap water from their homes or other public buildings. Slightly older kids could be doing walking field trips to streams or rivers that are near their school. They are going to also, if they go to those rivers, take the temperature of the water at that place. And all of the samples are going to be labeled with either the address or the GPS location of where the water came from. Each of those kids is then going to see a drop of that water under the microscope and find out what is actually living inside the water that they have collected. Your older kids can use chemicals to drop some things in, see what precipitates out, and determine what chemicals were in the water to begin with. Your middle schoolers might work with the county GIS office to create GIS maps. GIS maps are maps, electronic maps that have layers. So we would have a map of the county, and over it we would have a layer that shows the temperature of the water at different locations. And over that, another layer that would show us the chlorine content at different locations. And each layer can be turned on and off. This is a real-world skill that's beneficial in the world, and these kids are doing it for a real project. And your oldest kids could be doing hypothesis tests to determine, does our water actually meet the benchmarks of quality that are set by the state and the federal government? Now, what do we have when we're done? We have a project that is actually beneficial for the state or the municipal government, something that gives us a lot of information that we can actually use. And as this year goes on, hopefully other counties in the area say, wow, that's a great idea, we want to get involved. And the next year, it's a region-wide science project. And maybe eventually every county in the state wants to get involved. We have a statewide science project. And dare we dream that one day it's a nationwide science project? I say we dream, and I say we dare. It doesn't always have to be water quality. This year, water quality, maybe the next year's a population health study. Or we could look at road usage. There are lots of ideas, and I'm sure each of you could come up with 3 or 4 more. And now we've gained not only that important information that helps our government to make quality decisions, but we have an army of school children who have now engaged in science and seen science as important, seen science as relevant, seen science as beneficial to their community, and seen that science is fun. That's right, science is fun and important, and all of the things that they hope they can get out of sports, they can get out of science. And now there's a much better chance that they're going to stay engaged all the way through all of their education. Science is a game, and science is not a game that is merely meant for the pros. Science, I know, we're all imagining it, right? Science is a game that has no age limits. Anyone can get involved because science is, and always has been, a game without boundaries. Thank you.